so in today's tutorial in biochemistry, we'll be looking at a very important topic known as amino acids. So we'll take amino acids from the definition, we'll look at the bonds that hold amino acids, and we'll look at the classifications of the various amino acids based on different concepts. So let's start with the definition. We said our topic for today's class. The topic for today's class is amino acids. Amino acids. This is the topic for today's class. Now, definition. What is an amino acid? The definition. An amino acid is an organic compound that consists of three groups. An amino acid, amino acids are organic compounds. Amino acids are organic compounds that consist of three groups. The first group is the carboxyl group. They consist of the carboxyl group. The carboxyl group is the COOH group. This is the carboxyl group. They consist of the carboxyl group. The next, they consist of an amino group. They consist of an amino group, and an amino group is represented with NH2. And the last, they consist of a side chain. This side chain is always an alkyl group, I. So, let's look at the general structure of amino acids. The general structure of amino acids first. Okay, so we said an amino acid consists of a carboxyl group, an amino group, and a side chain. And we said the side chain is an alkyl group. Let's look at the general structure of an amino acid. The general structure of an amino acid, it consists of a central carbon atom. An amino acid consists of a central carbon atom that is bonded to a carboxyl functional group, COOH. It is bonded also to an amino group. This is an amino group. Or it is bonded to a hydrogen atom, and beneath it, it is bonded to a side chain. This side chain, the composition of this side chain in all amino acids tells the type of amino acid it is, whether essential or non-essential. Now, amino acids differ from each other by the composition of the side chain. That's a very important point to take note of. Now, we said amino acid, they consist of this central carbon. This central carbon is called the alpha carbon. The central carbon is called the alpha carbon. It consists of a carboxyl group. This is the carboxyl group. It consists of a carboxyl group. It also consists of an amino group. It consists of an amino group and a hydrogen, and also the side chain. This is the side chain. So when we talk about amino acids, we are looking at organic compounds that consist of a carboxyl group, they consist of an amino group, they consist of a hydrogen atom, and a side chain. And we said that the composition of various amino acids, they differ based on the constituents of the side chain. Okay, so we've looked at the various composition of an amino acid. We've looked at the general structure of an amino acid. Amino acid, a very important point to take note of, amino acids are linked covalently to each other by a peptide bond. Amino acids are linked together. Amino amino acids are linked, they are linked together, amino acids are linked together covalently. Covalently, it means the bond is a covalent bond. Amino acids are linked together covalently by a peptide bond. By a peptide bond. So the bond present in amino acid is called a peptide bond. The bond present in an amino acid is called a peptide bond. How is this peptide bond formed? A peptide bond is formed by the condensation. A peptide bond is formed by the condensation of an alpha amino group, and also an alpha carboxyl group. Condensation of an alpha amino group and an alpha carboxyl group. That condensation reaction forms a peptide bond. Now, let's explain in detail. If we have an amino acid, we said this amino acid are organic compound that consists of 3 substituents. I have an alpha carbon. This is my alpha carbon that is bonded to a carboxyl substituent, a carboxyl functional group. This is a carboxyl functional group, COOH. To the left is bonded to NH2. You bond carbon to carbon and you bond carbon to nitrogen. Alright? Now this carbon, this central carbon is called the alpha carbon. This central carbon, being called the alpha carbon, is bonded to the carboxyl group. Left, it is bonded to the amino group. Up, it is bonded to hydrogen. And beneath, it is bonded to a side chain. Let's take the side chain to be CH3. The name of this amino acid is called glycine. The name of this amino acid is called glycine. Alright? Now, we have one amino acid. We have one amino acid and another amino acid. We want to see how we form a peptide bond. We said the peptide bond is formed by the condensation of an alpha carboxyl group and an alpha amino group. Now, this is one amino acid called glycine. Let's take another amino acid. Let's draw the structure of another amino acid. This is COOH. Up, we have hydrogen. Beneath, we have NH2OH. Let me show the structure, the bonding of this. The bonding of this will look like, this is nitrogen bonded to 2 hydrogen atoms. This is the structure of this. And let's say beneath, we have just hydrogen or CH3. CH3, another glycine. Now look at this. We have 2 amino acids. Now, what do we mean? This carbon is called the central carbon, the alpha carbon or the central carbon. This is the alpha carbon, and this functional group is the carboxylic functional group. Now, what happens between these 2 amino acids to form a peptide bond? There is a condensation reaction, and in condensation reaction, there is loss of water. Now, what happens here is that there is loss of water between hydrogen and OH. So we are eliminating OH and hydrogen. So when we eliminate OH and hydrogen, we form a peptide bond. Alright, so eliminating this OH and H, this type of reaction is called a condensation reaction. A condensation reaction between the alpha carboxylic group and the alpha amino group forms a peptide bond. Now, when there is loss of water, you have a peptide bond formed between these 2 amino acids. Remember, the peptide bond is a bond that links 2 or more amino acids covalently together. The bond between 2 or more amino acids that links them covalently is called a peptide bond. So when there is condensation reaction, we have loss of water elimination of a molecule of water. Elimination of a molecule of water leads to the formation of a peptide bond. Now, what's left is just this acyl group and nitrogen with a hydrogen atom. Now, how do they link these two together? We just bring them together, we link them covalently. This bond between this amino acid and this is called a peptide bond. A peptide bond. So from here, the whole of this is called a peptide bond. A peptide bond is formed between the alpha carboxylic group and the alpha amino group. Why is it called alpha carboxylic group? Because this is the alpha carbon, and the carbon that is attached to this is this carboxylic functional group. So this is alpha carboxyl group and alpha amino group. The condensation between this alpha carboxylic group and the alpha amino group forms the peptide bond. There are two types of peptide bonds. There is a polypeptide bond and there is just a peptide bond, or you call it a monopeptide bond. The polypeptide bond is a bond between long chains of amino acids. The polypeptide bond is a bond between long chains of amino acids, but the monopeptide bond is a short bond between 3 to 4 chains of amino acids. Classifications of amino acids. Amino acids can be classified based on several parameters. But the classification that is more important to us is classification of amino acids based on nutritional requirements. So, in this aspect of classification of amino acids, we are looking at classification of amino acids based on nutritional requirements. Based on nutritional requirements, we have the essential amino acids, and the non-essential amino acids. Essential and non-essential amino acids. There's also a part called semi-essential, but that is just only one. But sometimes it is regarded as an essential amino acid. Now, what are essential amino acids? Based on nutritional requirements, amino acids are classified into essential and non-essential. What are essential amino acids? The amino acids, essential amino acids, are amino acids that cannot be synthesized or produced by the body. It means that these essential amino acids are gotten from diet. Essential amino acids, the major source of essential amino acids, are from dietary products. What we consume on a day-to-day life is the essential amino acids. The body cannot synthesize them, but they are being gotten from diet. Now, how do we remember these essential amino acids? How do we remember the essential amino acids? We can remember them with an acronym known as ACT, MU, and this MTU. Now, this alphabet, each alphabet, they represent various or different amino acids. Now, let's talk about the essential amino acids. Let's talk about the essential amino acids. Let's list them. The essential amino acids, the 10 essential amino acids, we said we can remember them with ACT here. What does the A represent? Arginine. Arginine is the first amino acid. The P represents phenylalanine. The T represents methionine. At here, the H represents histidine, the I represents isoleucine, the L represents leucine, the other L represents lysine. This act here, the M represents methionine, the T represents tryptophan, the V represents valine. So these are the 10 essential amino acids. And how do we remember them? We remember them with an acronym known as ACT, HEAL, and T. A very important exam question. So let's look at the 10 non-essential. We've looked at the 10 essential amino acids. Let's look at the 10 non-essential amino acids. Okay, so we've talked about the 10 essential amino acids. Let's talk about the other 10 non-essential amino acids. But before we talk about the other 10 non-essential amino acids, let's look at the definition of the non-essential amino acids. What are non-essential amino acids? Non-essential amino acids are amino acids that are synthesized by the body. They are synthesized by the body. These non-essential amino acids are gotten from two major ways. Number one is from direct conversion of the essential amino acids. And the second way is by amination of non-nitrogenous fragments. Non-essential amino acids, they have a sparring effect. Now, what do I mean by a sparring effect? It means these non-essential amino acids that are synthesized by the body, even if they are synthesized at minute or a greater quantity by the body, it is not being deficient or there is no lacking of these non-essential amino acids in the body. We said non-essential amino acids, the basic fact there is that non-essential amino acids are amino acids that are synthesized by the body. And we said these non-essential amino acids, they are 10 in number out of the 20. These non-essential amino acids are gotten from direct conversion of the essential amino acid. An example is the conversion of phenylalanine, which is an essential amino acid. Phenylalanine can be converted directly to a non-essential amino acid known as tyrosine. So, the conversion of phenylalanine, which is an essential amino acid, to tyrosine, which is a non-essential amino acid, is a way at which the body produces non-essential amino acids. Now let's talk about the 10 non-essential amino acids. The 10 non-essential amino acids. Let's talk about the 10 non-essential amino acids. The 10 non-essential amino acids. The 10 non-essential amino acids. Number one is aspartic acid. Aspartic acid. Number two is asparagine. Number three is cysteine. Number four is glutamic acid. Number 5 is glycine. Number 6 is choline. Number 7 is tyrosine. Number 8 is serine. Number 9, we have aspartic acid, asparagine. 16, glutamic acid, glycine, proline, tyrosine, serine. The last two are what and what? Alanine and what again? Yes? Alanine, and the last one is having a G. Glutamine. That is it. Glutamine. So these are the 10 non-essential amino acids. So let's have a quick recap on what we've discussed so far in amino acids. Let's have a quick recap on what we've discussed so far under amino acids. A quick recap, a summary of everything we've done under amino acids. Please take note, a very important point. Amino acids are responsible for all cellular activities in the body. So the function of amino acid is very vast. Amino acids are responsible for all the cellular functions of the body. Growth, development, repair of worn-out tissues. These are the functions of amino acids. Without amino acids, there won't be any genetic coding. Amino acid is responsible for virtually all cellular activities. Alright? So let's have a recap or a summary of today's class. Let's have a summary of today's class. We said amino acid is a short form for alpha amino carboxylic acid. The full name is alpha amino carboxylic acid, and we refer to that for short as amino acid. And we said this amino acid, they are organic compounds that consist of 3 functional groups bonded to this alpha carbon. They consist of a carboxylic functional group. They consist of an amino functional group. They consist of a hydrogen and a side chain. And we said that each amino acid differs from the other by the side chain. The differences in the alkyl group, which is this side chain, shows the various composition of the amino acid. And we said amino acids, they are linked covalently to each other by a bond called a peptide bond. And the peptide bond is formed between the alpha amino group of one amino acid and the alpha carboxylic group of another amino acid. And we went further to look at the classification of amino acids based on nutritional requirements. Based on nutritional requirements, they are classified into essential amino acids and non-essential amino acids. So this is what we can take for today's class. So until we come your way next time, subscribe.